Okay guys, here's part 2 of this video. So we just discovered that f of x equals absolute value of x can also be written as f of x equals x with the domain of x is greater than or equal to 0 and negative x where x is greater than 0. But it also, absolute value of x can also be expressed as the square root of x squared. So let's prove that that's true. If I take 3 and plug it in to both of them, I do get a true sentence. But also if I plug in negative 3, I'll wind up with a true sentence. So therefore, we can now also say that if the square root of x squared, if the square root of x squared is equal to absolute value of x, and absolute value of x is equal to this, we now can conclude that the square root of x squared is also equal to this piecewise function. Again, so a little bit here that we need to try and memorize. So I'll show you like how we would do an example of that. All right, so if I gave you f of x equals the square root of x minus 8 squared, and I wanted you to write it as a piecewise function, we would separate it. And now think about this. So this really is taking the line y equals x and moving it horizontally to the right 8. Right, so it's going to get moved all the way over here to the right 8. But then I also want to have the negation of that line, which will go this way. So all we're going to do is write the piecewise function as the equation of both of those lines. So let's do the first one. This guy I'll do right here. And this one would just be the line, x minus 8. And what would the domain be? Well, I just moved it over 8. So the domain would be x is greater than or equal to 8. Somebody has to get the equal to, so I usually just give it to the first one. Then I want to write the equation of the second piece. And I'll put that right here. Now, just like we did before when we wrote the piecewise function and you had, remember we had x and you had negative x when we wrote the piecewise function? So this will also be the negation of x minus 8. And then what is the domain? The domain for this guy is going to be going the other direction. So x is less than 8. Okay, so that would be an example of how we could write f of x equals the square root of x minus 8 squared as a piecewise function. All right, so that's probably the hardest part of that for today. But maybe you just have to go back and you just have to just watch the video again, pause it, and try to really get it in your head. Okay, so next part is easy. Next part is just going to be reviewing rationalizing the denominator, which we're all great at from Algebra 2 and from this year as well. But let's just practice and make sure that we are indeed good at it. Let's make that a little smaller. Okay, so if we want to rationalize the denominator, remember I'm going to multiply by 3 minus rad 5 over 3 minus rad 5, which is the conjugate of the denominator. Distributive property on top, 18 minus 6 rad 5. And remember, you don't really want to FOIL on the bottom. You want to just use dots. Take the first one and square it. Take the second one and square it. Put a minus sign between it. So we're left with 18 minus 6 rad 5 over 4. But we do need to simplify. So we look for the GCF of all three of those guys. So we have 9 minus 3 rad 5 over 2. Okay, a little review of rationalizing. Let's try another one. Remember, we're going to multiply by the conjugate of the denominator. So 5 plus rad 3 and 5 plus rad 3. Distributive property on top. 30 plus 6 rad x over, again, we don't need to FOIL on the bottom or distribute out. Let's just dots So 25, take the first one and square it, take the second one and square it, and a minus sign between them. There's no simplifying to do there, so that guy's good. Remember, you can always pause, rewind, do whatever you need to do. I'm just going to keep on going so these videos aren't a million years long. Okay, so again, let's rationalize the denominator. So I'll multiply by the conjugate. Okay, now here, I have a binomial on top. We're not going to distribute on top. Leave it. And something nice will happen here. Okay, dots on the bottom. Take the first one and square it. Take the second one and square it. Minus sign between them. And hopefully you guys remember this right here. Remember this? Oh, I should have used a different color. That's the -1 rule. So those guys wipe out to be -1. So my answer is negative rad x plus 5. So if you don't remember the -1 rule, the -1 rule is when you have a minus b over b minus a. This will always reduce to -1. So you can memorize that if you don't have that memorized. Okay, so something a little new that we're going to do, that we're going to need in our limits unit, is being able to rationalize the numerator as well. When we rationalize the numerator, it's the same exact thing as the denominator. And there'll be times that we have to just, make the appearance change, but it'll still be equivalent. And that's what we're doing. We're rationalizing the denominator as well. So let's rationalize the numerator. Again, you just multiply by the conjugate. I like to put parentheses around all binomials. And we'll do like we did at the one up top. So it'll be dots on top. Take the first one and square it. Take the second one and square it. Put a minus sign between them. And then on the bottom, we don't need to FOIL that out. And that would be sufficient. There's no reducing that could be done there. And these are we're just practicing some tools that we're going to use later in this unit. Okay. Whoa, now we're getting fun here. Okay. So we're rationalizing again, but you have to see this as, like, it looks confusing, but don't look at it that way. Just look at it as that's the first term, and that's the second term. So let's rationalize the denominator again. I multiply by the conjugate, so it's rad 2x plus 1 plus rad 3. Rad 2x plus 1 plus rad 3. My daughter's chopping celery in the background.
I don't know where else to go.
Sorry for the noise.
Sorry, everyone.
All right, so here we go. All right, so we got dots on top. Look, you're still taking the first one and squaring it. So isn't it just released from the radical? So 2x plus 1. Take the second one and square it. So it's released from the radical. Put a minus sign between it. And now on the bottom, just like we did before, when things get this complex, you don't have to multiply it out because something special happens. All right, so I don't have tons and tons of space on here. Does everybody see that this top becomes 2x minus 2, right? Does everybody see that? That's what this top piece becomes. And then isn't that what this guy is right here? So these guys wipe out. So my answer is 1 over rad 2x plus 1 plus 3. Okay. And there we go. All right, another one. Okay, so let's rationalize the denominator. All right, just hold on 1 second. I can't pause this video. See, there's another one in the refrigerator on the bottom shelf. Okay. All right, I'm back. So let's rationalize the numerator. So rad x plus rad 6 rad x plus rad 6. I like to put parentheses around all my binomials. So I hope you don't mind, but I'm going to erase this up here so I can have a little more room now. Okay, let's do the top. Take the first one and square it. Take the second one and square it. Put a minus sign between it. And then on the bottom, hopefully you're seeing the pattern now. Don't distribute that out because these guys are gone. And I'm left with 1 over rad x plus 6. And there we go. Remember, pause, rewind, do the question again, whatever you need to do. Yep, looks difficult, but it's not. This is just the first term. This is just the second term. So we're doing the same exact thing. Let's rationalize the numerator. Okay, so dots on top. Take the first one and square it, so it's just released from the radical. Take the second one and square it, it's released from the radical. Put a minus sign between them. All right, on the bottom. So on the bottom we have h. You don't have to distribute it. H times rad 2x plus h plus rad 2x. If we simplify the top, we see that these guys wipe out. And then we also see that the h's cancel. So I'm left with 1 over rad 2x plus h plus rad 2x. Rationalizing the numerator, okay? And this will be something that we're going to use in our limits unit. It'll just be a tool to just transform it into something equivalent. Okay, next part of review here. We just have to review the horizontal asymptote rules. We'll be using these as well. So remember, if I give you a function and I want you to find out if there is a horizontal asymptote, you compare the highest degree of the numerator with the highest degree of the denominator. So here I'm comparing 3 and 4. So 3 is less than 4. Anytime your numerator is less than your denominator, it's just y equals 0 every time. If the highest degrees are equal, then it's equal to the ratio of the coefficients, which is 2 over 1. So the horizontal asymptote is y equals 2. And remember, if n is greater than d, then there is no horizontal asymptote. All right, so let's, let me see, did I put some practice questions in here? Oh, no, okay, so I'm gonna I'll write in a couple practice of those so we could just do that real fast. Okay, so just write these in. So if I give you, oh, that's no good. Let me get a skinny one. Okay, if I give you f of x equals 3x squared minus 5x to the 4th over 2x to the 4th plus 1, and I want to know if there is a horizontal asymptote. We have to compare the highest degrees, so I would be comparing right here. And I can see that n equals d, so therefore the equation of the horizontal asymptote is equal to the ratio of the coefficients, so negative 5 over 2. Okay, let's try another one. F of x equals 8x cubed plus x over x squared plus 9. Again, let's compare the highest degree of the numerator with the highest degree of the denominator. In this case, we have n is greater than d, so therefore there's no horizontal asymptote. Okay, and then one more. Let's do y equals 4x squared minus x cubed over x to the 5th minus 3. Let's compare the highest degree in the numerator with the highest degree in the denominator. In this case, n is less than d. Anytime n is less than d, the equation of the horizontal asymptote is y equals 0. Okay, so all today was just a review of things that we know from the past that we are going to use in our limits unit, and then just that one new thing I did with the piecewise functions. So that's it. Hope that was good. Miss hearing your voices, especially some people who talk every single day the whole period. Okay, that's it. Bye.